Right now, you are hurtling through a dark void at 828,000 kilometers per hour. It is a number so large that it feels like a calculation gone wrong, a theoretical abstraction rather than a physical reality. But this is confirmed science. In the time it takes you to hear this sentence, everything you have ever known, your home, your city, the ground beneath your feet, has moved roughly 60 meters through space. You feel absolutely nothing. Your coffee sits still in its cup. The room around you is silent. There is no wind, no acceleration, and no sense of the staggering velocity that defines your existence. This is because you are being carried in perfect harmony with everything in your local environment. The Earth, the Sun, and all the nearby stars are moving together like dancers in a slow waltz, all keeping the same rhythm. We are passengers on a colossal structure, a 13-billion-year-old spiral made of hundreds of billions of suns. It is a structure so vast that light itself, the fastest thing in existence, takes 100,000 years just to cross it from one edge to the other. If this is the kind of deep investigation into the mechanics of our reality that interests you, subscribe now. The investigation begins with the most fundamental mystery of our home, the fact that we are living inside a ghost we cannot see. To understand the scale of our ignorance, you must first look at the stars you see on a clear, moonless night. Away from the orange glow of city lights, the sky seems like an infinite ocean of light. But it is barely a droplet. Under the best possible conditions, you can only see about 0.00003% of the Milky Way with the naked eye. The pale, hazy streak that crosses the sky is just the innermost whisper of the whole. Most of our galaxy is hidden from view, tucked behind thick curtains of interstellar dust or lying so far away that its light will never reach your retinas. We have mapped the distant edges of the observable universe, yet we have seen less than 1/10,000th of our own home. We are living inside a cosmic puzzle box. For thousands of years, every person who ever looked up at the sky saw that band of light but could not grasp what it meant. They made up stories, created myths, and assigned divine significance to the Silver River or the Milky Circle. The truth is much more profound. We are embedded so deep inside one of the galaxy's spiral arms that seeing its full shape is like trying to understand the layout of a city while standing in the middle of a crowded intersection. The view is blocked by what is closest to you. Our star, the Sun, is not sitting at the center of the system. We are located about 27,000 light-years from the galactic core. We reside in a relatively quiet lane of stars known as the Orion Spur. This narrow structure is a kind of galactic side street, tucked between two major highways, the Sagittarius and Perseus arms. This position is not just a location, it is a perfect balance. We are far enough from the violent, radiation-blasted core to avoid its chaos, but close enough to remain part of the galaxy's vibrant star-forming disk. In this quiet corner, between the grand spiral arms, massive supernovae are rarer, and radiation storms are less frequent. This minor position may have been the very thing that gave life on Earth the billions of years of peace it needed to emerge and evolve. But even in this stable neighborhood, nothing is truly still. The Sun follows a long, complex orbit shaped by the galaxy's gravity. One full loop around the galactic center takes roughly 230 million years. Astronomers call this a galactic year. It is a cycle of motion so vast that it dwarfs every calendar humans have ever created. Consider the depth of that time. In the 4.6 billion years that the Sun has existed, it has only circled the Milky Way about 20 times. That is our cosmic odometer, 20 laps. The last time our solar system was in this exact part of the galaxy, the supercontinent Pangaea had just begun to break apart. The first dinosaurs were only just beginning to emerge. Human civilization in comparison is a flicker, a fraction of 1% of a single galactic orbit. We often think of the stars as ancient and unmoving, but we are part of a current, and we are drifting in it. As the Sun journeys forward, it doesn't follow a perfectly flat path. Instead, it bobs up and down through the galactic plane like a cork in slow motion. This vertical oscillation is caused by the gravitational tug of the galaxy's mass, pulling and releasing the solar system as it moves. Each rise and fall takes tens of millions of years. Right now, we are slightly above the midplane, moving upward. In about 10 million years, we will reach the peak of our oscillation before falling back down through the plane. Some scientists have speculated that these passages through the densest part of the disk might expose Earth to increased cosmic ray bombardment or gravitational disturbances, possibly triggering climate changes or mass extinctions. The evidence is not yet certain, but it serves as a reminder. Even on its steady path, the Sun is swaying softly through a space-time that is more dynamic than we can imagine. The galaxy itself is not a static object. It is a living system. It moves, it breathes, and it changes. By all logic, the Milky Way should not even exist. This is what the data says. When astronomers measure the mass of every star, every planet, and every gas cloud we can see, the numbers do not add up. The outer edges of the galaxy are spinning far too fast. Based on the visible matter alone, those outer stars should be flung into space like leaves in a storm. Something unseen is anchoring them in place. That something is dark matter. It accounts for roughly 85% of the galaxy's total mass. It does not shine, it does not reflect light, and it does not emit any radiation we can detect, yet it exerts gravity. It is the invisible scaffolding, the dark skeleton that holds the entire structure together. Without this invisible hand, the Milky Way's spinning disk would unravel like a carousel with no axle. We are living in a mature spiral, glowing gently in its middle age. But the galaxy we know today is not the one that was, and it is not the one that will be. Its silhouette has shifted over billions of years like a drifting cloud. The Milky Way was not born in peace. It was built in battle. More than 13 billion years ago, it began as small, chaotic dwarf galaxies that were bright, unstable, and crowded with young stars. Gravity pulled them together. They collided, they merged, and they became a growing gravitational seed. Our home is a composite structure, stitched together from the ruins of 1,000 smaller worlds. We are actively consuming our neighbours right now. This isn't speculation. It is documented and measured. Astronomers have discovered long ribbons of stars, stellar streams, stretching across the sky like ghostly rivers. These are the remnants of smaller galaxies that wandered too close and were pulled apart strand by strand by the Milky Way's gravity. We carry the rings of our past in every thread of light. Even the disk of our galaxy is not perfectly flat like a textbook diagram. It bends and warps at the edges, curving upward on one side and downward on the other like a soft wave frozen in space. This distortion, known as the galactic warp, is a scar, evidence of past encounters with satellite galaxies that brushed past and twisted our edges. We are riding a 13-billion-year-old spiral that is still growing, still breathing, and still keeping secrets. We have mapped the stars, but we have not yet understood the dark. We have measured the velocity of our sun, but we do not know what lies at the heart of the great attractor pulling us forward. Every fact we uncover pulls the ground slightly further from under our feet. The investigation into these 100 mysteries is ongoing, and as you sleep, the galaxy continues its patient, 230 million-year orbit. We are small, the universe is enormous, and that is the most interesting thing we know. Tonight, we step outside our brief moment in time to glimpse the vast river that carries us through the universe. We are travellers aboard a moving world on a journey we can neither steer nor stop, and the story is just beginning. For thousands of years, every person who ever looked up at the night sky was looking at a lie. They saw a pale, hazy streak of light stretching from one horizon to the other. To the ancient Greeks, it was a splash of divine milk. To the Romans, it was the Via Lactea, a road of light. To Chinese astronomers, it was the Silver River. They made up stories, created myths, and assigned profound significance to this celestial ribbon. but they could not grasp the simplest, most fundamental truth about it. They didn't know they were standing inside of it. For nearly the entire history of our species, we believed that Earth sat at the centre of a random scattering of lights, and that the Milky Way was merely a strange, luminous cloud drifting among them. We lived in a house for 200,000 years without ever realising we were inside a room. The first person to glimpse the true geometry of our home wasn't even a trained astronomer. In the late 1700s, William Herschel was a musician living in England, a composer who taught himself astronomy as a hobby. He didn't have access to modern observatories. He built his own telescopes, grinding the mirrors by hand in his basement. A painstaking process that could take months for a single piece of glass. Herschel didn't just look at the sky. He conducted a systematic investigation. He spent night after night standing in the cold English air, counting stars. He would point his telescope at a specific region, count every faint point of light he could see, record the number by candlelight, and then move to the next patch. This is what the data revealed. Herschel discovered that stars were not scattered randomly. They formed a flattened disk, a structure with width and depth, but very little height. This is confirmed science. He used a simple but effective analogy. Imagine a dinner plate covered with grains of sand. That is our system. He realized that the reason we see a band of light in the sky is that we are looking edge-on through the thickness of that plate. But even Herschel, with his years of counting, couldn't see the full picture. The distance was too great and the view was obscured. He saw the disk, but he couldn't see the spiral. The realization that our entire universe of stars was just one island among millions didn't arrive until 1924. Edwin Hubble, working with the 100-inch Hooker telescope in California, the largest in the world at the time, was studying what people then called spiral nebulae. Most scientists assumed these were just clouds of gas within our own system. But Hubble was looking for a specific type of star called a Cepheid variable. These stars pulse with a regular rhythm, and their pulse rate is directly tied to their true brightness. They are cosmic measuring sticks. When Hubble calculated the distance to the Andromeda Nebula, he found a number that shattered our understanding of reality. 1 million light-years. It was a distance far beyond any reasonable boundary of the Milky Way. In that moment, the universe became unimaginably larger. We weren't the centre of everything. We were residents of one spiral galaxy among billions. But here is the complication that persists to this day. Even though we know we're in a spiral, we don't actually know what our galaxy looks like. It seems like something we should have mastered by now. We have mapped the surface of Mars in high resolution and photographed galaxies 13 billion light-years away. Yet, our own home remains a mystery. We still don't know exactly how many spiral arms the Milky Way has. For decades, the consensus was that there were 4 major arms. More recent observations have suggested there might only be 2, with several minor spurs or fragments filling the gaps. Some astronomers disagree entirely, arguing that the arms twist and split in ways more complex than any neat pinwheel diagram would suggest. The reason for this ignorance is simple: our position. We're embedded 27,000 light-years from the centre, deep inside the disk. Trying to map the Milky Way from Earth is like trying to understand the layout of a vast forest while standing in the middle of a dense thicket of trees. Your view of the distant forest is blocked by the trees closest to you. In our case, the trees are interstellar dust. This dust, made of microscopic grains of carbon and ice, weaves through the galaxy in thick, murky clouds. In visible light, it acts like a dense fog, blotting out the light of hundreds of billions of stars. We can see the stars in our local neighbourhood, but we're effectively blind to the far side of our own galaxy. This is not speculation. If we could fly a camera 100,000 light-years above the galactic plane and look down, the image would likely surprise us. It would not be the clean, geometric spiral shown in your high school textbooks. To understand why, we have to look at what spiral arms actually are. We often imagine them as solid roads of stars, like the blades of a fan spinning in the dark, But if they were solid structures, they would have wound themselves up and disappeared billions of years ago. Instead, they are traffic jams of density waves. Think of a highway. The cars are the stars and they're all moving forward at high speeds. But at certain points, for reasons of gravity, the cars have to slow down. They bunch together, creating a dense cluster, a traffic jam. Eventually, each car speeds up and exits the jam, but the jam itself stays in the same place. The spiral arms are the traffic jams. As gas and dust clouds drift into these regions of higher density, they are compressed. Gravity takes over, and the clouds collapse, triggering bursts of star formation. This is why the arms glow so brightly. They are filled with hot, massive, newborn stars that illuminate the jam like neon lights. Individual stars, including our Sun, are constantly drifting in and out of these patterns. We are passengers on a moving current, riding the wave for a few million years before moving back out into the quieter, darker spaces between the arms. But as we have peered deeper into the heart of this traffic jam, we have discovered that the geometry of our home is even more distorted than we imagined. When astronomers began mapping the centre of the galaxy using infrared light, which can pierce through the dust fog, they found something that defies the standard sphere model of a galactic core. The Milky Way has a peanut-shaped bulge. If you could see our galaxy from the side, the centre wouldn't look like a smooth round ball of stars. It would look like a 3D peanut or a twisting hourglass. This strange shape is likely caused by the galactic bar, a dense stripe of stars crossing the core that has buckled and puffed upward over billions of years of motion. Our home is not symmetrical. It is not a perfect pinwheel. It is lopsided. One side of the disk appears thicker than the other. Some spiral arms are longer and brighter than their counterparts, and at the very edges the disk doesn't lie flat. It bends and warps, curving upward on one side and downward on the other like the brim of a hat that has been left in the sun too long. This galactic warp is a scar. It is a physical record of the Milky Way's violent history, a ripple frozen in space caused by the gravitational tug of satellite galaxies that brushed past us eons ago. We are living inside a structure that is constantly flexing, bending, and changing form in response to invisible forces. The shape of a lie is the realization that the clean, stable, circular galaxy we were taught to imagine does not exist. Our home is a layered, twisted, distorted sculpture of motion. We have measured the velocity of the stars and the wobble of the disk, yet we are still like those ancient astronomers looking at the Silver River, trying to piece together the truth from fragments of light. The investigation into the geometry of our home is ongoing. Every year, missions like Gaia are mapping the positions of over 1 billion stars with exquisite detail, slowly turning that hazy smear of light into a sharp, living map. But for every coordinate we fix, a new complication emerges. We have mapped the stars, but we have not yet understood the dark scaffolding that holds them. We have seen the peanut at our core, but we haven't explained why it refuses to settle into a sphere. Our home's geometry is a puzzle we are still learning how to solve, and as we move from the shape of the galaxy to the monsters that anchor it, the mysteries only get deeper. At the absolute centre of our galaxy, there is no lighthouse to guide the way. Instead, there is a shadow that rules by gravity. For decades, this region remained a forbidden zone for astronomers. It sits roughly 27,000 light-years away from you, tucked behind thick curtains of interstellar dust and gas that block all visible light. If you were to look toward the constellation Sagittarius with your naked eye, you would see nothing but a dark rift in the stars. But we have learned to listen in other frequencies, radio waves, infrared light and X-rays, to see through the cosmic fog. This is what the data revealed. Near that invisible point, entire clusters of stars race through space at thousands of kilometers per second. Their orbits are not random. They follow perfect, mathematically precise curves that trace the shape of a deep, unseen well. In the 1990s, multiple independent teams began tracking these stars year after year, watching them whip around a void. The result of this investigation was a number that changed our understanding of the universe. At our centre sits Sagittarius A star, a supermassive black hole with the mass of 4 million suns. Every single one of those millions of stars has been compressed into a region of space smaller than the orbit of the planet Mercury. This is confirmed science. The density is so extreme that if you were to stand near its edge, the gravity would warp time itself. A clock carried on a tight orbit near this object would tick measurably slower than one on Earth. But here is the complication. By all rights, our galactic centre should be a place of blinding, violent light. In other galaxies, supermassive black holes act as active engines known as quasars. They guzzle down stars and gas clouds, heating that material to billions of degrees and launching jets of radiation that outshine their entire host galaxies. Yet, a monster is quiet. Sagittarius, a star, is currently sleeping. It is not actively devouring large quantities of matter. Instead, it is sipping only small amounts of gas and dust that drift too close. It is the silent conductor of the Milky Way's heart, pulling stars into a slow, relentless dance while remaining tucked in the dark. However, this silence is deceptive. We know it was not always this calm. High above and below the galactic plane, we have discovered the Fermi bubbles, two colossal lobes of high-energy gamma radiation ballooning out 25,000 light-years into space. These are the fossil records of a violent feeding episode that likely occurred a few million years ago, around the time early human ancestors were first walking the Earth. The bubbles are the marks of a giant that briefly bore its fangs. This leads us to one of the most puzzling mysteries in modern astrophysics, the G2 anomaly. In 2014, astronomers observed a dusty gas cloud named G2, about 3 times the mass of Earth, heading on a direct collision course with the event horizon. This was a moment the scientific community had waited decades to see. Calculations suggested the black hole's intense tidal forces would shred the cloud like a ribbon in a blender, triggering a massive flare of X-rays as the monster finally fed. But the encounter was an anticlimax. G2 passed within the black hole's reach and survived. It emerged from its closest approach largely intact, continuing its orbit as if nothing had happened. This survived encounter has forced us to reconsider what G2 actually is. The leading theory now is that it wasn't a simple cloud at all, but a young star shrouded in a massive cocoon of dust. This answer only creates a deeper layer of complication. If G2 is a star, how did it form there? The tidal forces near a 4 million solar mass predator are so violent that they should prevent gas from ever collapsing into a star. Gravity near the core is so intense and changes so rapidly that any nursery for stars should be torn apart before the process can even begin. We are finding a city of young stars in a place where it should be impossible for them to be born. To find the truth, we must look closer than we have ever looked before. The stars closest to the black hole are known as the S-stars. Among them, a star named S2 has become our most important laboratory for fundamental physics. S2 follows a long elliptical orbit, completing one full loop every 16 years. At its closest approach, it moves at roughly 3% of the speed of light, about 20 million miles per hour. Watching S2 is like watching gravity in its purest form. This is established. As S2 swings past its closest point, its light is stretched to longer wavelengths by the black hole's mass, an effect known as gravitational redshift. It matches Einstein's predictions of general relativity to extraordinary precision, but we are now searching for an even more subtle effect. If Sagittarius A star is spinning fast enough, it may be doing something truly alien. It may be dragging the fabric of space-time itself. This phenomenon, known as frame dragging, suggests that a rotating black hole doesn't just pull on matter. It twists the 4-dimensional grid of our reality like a spoon being turned in honey. This dragging would subtly alter the orbits of nearby stars and gas, nudging the inner flow of the galaxy into warped processing patterns. We are living inside a structure anchored by a shadow we cannot see, yet we can weigh it, map its spin, and watch it flicker. The investigation into the heart of our galaxy took a massive leap forward in 2022. A global network of radio telescopes, acting as an Earth-sized lens, captured the first direct image of the region surrounding Sagittarius A star. It did not show the black hole itself, nothing can escape from within its event horizon, but it revealed a glowing ring of superheated matter swirling around it. It was the face of the monster. This glowing ring is the shadow of the black hole, a dark circle carved into space-time. It confirmed that supermassive black holes are not rare cosmic accidents, but the fundamental anchors of almost every large galaxy in the universe. Despite its monstrous nature, we owe our existence to this balance. The black hole acts as an invisible flywheel that keeps the galaxy's choreography in time. It stabilizes the central bar and the dense nuclear cluster, setting the pace at which the spiral pattern breathes. If the heart were too active, it could choke the galaxy with radiation. If it were too quiet, the inner disk might drift. We are part of a delicate gravitational ballet. Every star you have ever seen, every planet we have discovered, and every arm of this spiral dances to a rhythm set by a darkness sitting at the very center of everything. The investigation is ongoing, and as our instruments become more sensitive, the monster that anchors us is slowly beginning to reveal its secrets. We have seen its shadow, measured its mass, and confirmed its grip on the laws of physics. But as we move from the core to the vast hidden graveyards that surround it, the story of our home becomes even more unsettling. Somewhere inside the Milky Way there are roughly 1 billion stellar corpses. It is a number that is difficult to hold in the mind. If you were to try to count them, one by one, at a rate of 1 per second, it would take you more than 30 years of continuous effort just to finish the list. But these are not merely numbers on a page. They are physical objects drifting through our immediate neighborhood. This is confirmed science. When you look up at the night sky, you see the living, the bright burning suns that define the shape of our spiral home. But for every star you can see, there are ghosts you cannot. Our galaxy has been manufacturing these remains for over 10 billion years, and today, we are living inside a cemetery of unimaginable scale. To understand the nature of this graveyard, you have to look at the way a star ends. For a star like our Sun, death is a slow, relatively quiet expansion into a red giant before it sheds its outer layers to leave behind a white dwarf, a cooling ember the size of Earth. But for the massive giants of the galaxy, the end is a violent catastrophe. When a star with at least 8 times the mass of our Sun exhausts its fuel, it does not simply fade away. It collapses in a fraction of a second, triggering a supernova explosion so powerful it can outshine all 100 billion stars in the galaxy combined. This is not speculation. We have measured the energy of these events across the cosmos. What remains after the smoke of the explosion clears is a stellar corpse of terrifying density. A neutron star or a black hole. Consider the physical reality of a neutron star. It is an object that packs more mass than our entire Sun into a sphere roughly the size of a city, perhaps 12 miles across. This is established science. Because the density is so extreme, the laws of physics as we know them on Earth cease to function. If you could somehow take a single teaspoon of material from the surface of a neutron star and bring it to Earth, that teaspoon would weigh more than a mountain. It would weigh approximately 6 billion tons. If you dropped it, it would not sit on the ground. It would punch through the crust of our planet like a stone through tissue paper, sinking toward the core. These are the inhabitants of the galactic graveyard. They are city-sized bullets of pure mass, spinning hundreds of times per second and broadcasting radio pulses like cosmic lighthouses. We call them pulsars. But here is the discovery that changes the way you look at the jewelry on your hand or the electronics in your pocket. The galaxy is like a graveyard that makes jewelry. For decades, scientists struggled to explain where the universe's heaviest elements, like gold, platinum, and uranium, actually came from. Supernovae produced some, but the math didn't quite add up to the quantities we see on Earth. The answer was found in the most violent encounters possible within the graveyard. The collision of 2 stellar corpses. When two neutron stars, locked in a gravitational embrace for eons, finally spiral together and collide, they create an event known as a kilonova. In a single fraction of a second, the pressure and heat are so intense that neutrons are crammed into atomic nuclei by the quadrillion. This process, known as the R process, is the cosmic forge. This is what the data says. Every single gram of gold on Earth was forged in a collision like that. Every wedding ring, every gold contact in your smartphone is a piece of ancient stellar wreckage. We are walking through a history written in the debris of dead suns. But the graveyard is not a place of stillness. It is a place of restless, invisible motion. This brings us to the complication. The stellar bow shocks. Most stars drift through the galaxy at a relatively leisurely pace, but some of these stellar corpses are moving at extreme velocities, hurtling through the thin gas of the interstellar medium like runaway trains. Because they are dark, we cannot see the objects themselves, but we can see the waves they leave behind. As one of these high-speed corpses ploughs through the galactic gas, it creates a bow-shaped shockwave, similar to the wave formed by the hull of a boat moving through water. This shock compresses and heats the surrounding gas, causing it to glow in infrared and visible light. When astronomers point their telescopes into the dark, they sometimes find these glowing arcs, luminous curves of fire that mark the path of an invisible predator. It is a haunting sight, a signature of motion from a ghost we cannot otherwise detect. The deeper layer of this mystery involves why these corpses are moving so fast in the first place. Some are kicked by the uneven nature of the supernova explosion that created them, sent flying across the disk like a ball from a cannon. Others have a more sinister origin. This leads us to a deeper complication: the hypervelocity refugee stars. Deep in the heart of the galaxy, the supermassive black hole Sagittarius A* acts as a gravitational catapult. When a binary star system, two stars orbiting each other, wanders too close to the core, the black hole's gravity can capture one star and hurl the other outward at speeds exceeding 1 million kilometers per hour. These stars are moving so fast that they have reached escape velocity. They are no longer bound by the gravity of the Milky Way. They are being kicked out of their home forever. We have identified dozens of these refugees so far. They carry no return ticket. They are solitary pilgrims racing away from the spiral arms and into the great dark between galaxies. And here is where we find our honest uncertainty. We do not know where the most energetic of these stars are going once they cross the boundary of our galaxy. Space between galaxies is not merely empty. It is a void so vast that light itself takes millions of years to cross it. Are these stars doomed to burn out alone in the dark, becoming cold, dead remnants in a space where no other star will ever see their light? Or are they the seeds of something else? Intergalactic wanderers that will eventually fall into the gravitational grip of another galaxy, like Andromeda, billions of years from now? The investigation is ongoing, but for now, we only know that they are leaving. They are the ultimate witnesses to the violence of our galactic centre, carrying the chemical signatures of the Milky Way into an eternal exile. We often think of our galaxy as a stable, permanent structure, but the graveyard tells a different story. It tells a story of a system that is constantly being recycled, where the death of one generation provides the jewellery and the bones for the next. You are a participant in this cycle. The iron in your blood, the oxygen in your lungs, and the gold on your finger were all forged in the violent hearts of the corpses we have explored tonight. We are living inside a 13 billion-year-old system that is still growing, still breathing, and still keeping secrets. We have mapped the stars, but we have not yet understood the dark scaffolding of the dead. As you sleep, the galactic graveyard continues its silent, patient rotation. Each of those billion corpses is a data point in a story we are only just beginning to read. We are small, the universe is enormous, and that is the most interesting thing we know. The investigation continues. When you look at a photograph of the Milky Way, you see a structure that appears to be the very definition of cosmic order. You see a graceful, luminous pinwheel, its arms curving with a mathematical elegance that suggests a history of peaceful, steady growth. But this is a lie. The Milky Way was not born in peace. It was built in battle. Our home is a composite structure, a patchwork quilt stitched together from the wreckage and ruins of thousands of smaller worlds. We are living inside the stomach of a predator. This is confirmed science. For decades, we viewed our galaxy as a pristine spiral, a singular entity that formed from a single collapsing cloud of gas. But as our instruments have become more sensitive, particularly with the arrival of the Gaia mission, a different story has emerged. We have discovered that the Milky Way has spent the last 13 billion years actively devouring its neighbours. Right now, as you listen to this, a small system called the Sagittarius Dwarf Galaxy is being torn apart. It made the mistake of drifting too close to our gravitational grip, and now it is being unravelled. Astronomers have mapped long ribbons of its stars, known as stellar streams, looping around the Milky Way like spaghetti being pulled into a drain. These streams are the rings of our past, etched into the sky like the growth rings of a tree. They are the physical evidence of a long history of galactic cannibalism. To understand how we know this, you have to look at the stars themselves as if they were evidence at a crime scene. This field is known as galactic archaeology. Every star carries a unique chemical fingerprint imprinted at the moment of its birth. Stars born inside the Milky Way tend to have higher concentrations of heavy elements, what astronomers call metals, because they were forged in a dense environment where generations of supernovae had already enriched the gas. But when we point our telescopes at the outer edges of our galaxy, we find thousands of stars that don't belong. Their chemistry is primitive, mostly hydrogen and helium with almost no heavy elements. Their orbits are even more telling. While most stars in the disk orbit the centre in a neat flat circle, these immigrant stars follow wild, elongated paths, some even orbiting backward against the main rotation of the galaxy. This is established. These stars are the survivors of ancient systems that the Milky Way destroyed. In a very real sense, some of the light you see in the night sky is the glow of refugees from galaxies that no longer have names. But the most significant discovery in this investigation came just a few years ago. By analysing the coordinated motion of over 1 billion stars, multiple independent teams identified a single, massive collision that changed everything. It is known as the Gaia Sausage-Enceladus merger. Roughly 10 billion years ago, a dwarf galaxy containing about 600 million times the mass of our Sun plunged into the young Milky Way. It was a head-on collision of unimaginable scale. Imagine a smaller, energetic ship slamming into the side of a larger growing vessel. The impact didn't just add stars to our population, it physically thickened our disk. It stirred up the existing stars, puffing them outward and creating the thick disk layer that we still see today. A puffier, more diffuse region of older stars that sits above and below the main plane where we live. That single event changed our geometry forever. It was the moment the Milky Way transitioned from a chaotic collection of fragments into the massive dominant spiral we recognise. But here is where the story takes a dark and unsettling turn. This is what the data reveals, and it points to a massive gap in our understanding of reality. According to our best mathematical models of the universe, the cold dark matter model, a galaxy the size of the Milky Way should be an even more aggressive predator than we observe. The math says that we should be surrounded by thousands of small satellite galaxies. Our gravitational reach is so vast that we should have captured and held onto a cloud of thousands of tiny companions, each tucked inside its own dark matter halo. Yet, when we look through our telescopes, we find a different reality. We have only observed roughly 50 satellite galaxies. This is known as the missing satellite problem. It is a mathematical crisis that strikes at the very heart of how we think the universe works. If the physics we use to explain the expansion of the universe and the motion of the stars is correct, then there is a massive discrepancy between what we predict and what we see. Where are the missing thousands? There are two primary theories, and both are equally haunting. The first is the ghost galaxy theory. It suggests that the thousands of missing satellites are actually there, orbiting us right now, but they are completely invisible. They are galaxies made almost entirely of dark matter, with so few stars that they emit no light we can detect. We are living inside a swarm of thousands of dark, silent companions that we have not yet learned how to see. The second possibility is more fundamental. We might be wrong about how galaxies grow. It is possible that our understanding of gravity or the nature of dark matter is flawed. Some scientists have proposed modified Newtonian dynamics, MOND, suggesting that gravity behaves differently on galactic scales than it does on Earth. If our math is wrong, then the thousands of predicted galaxies were never there to begin with, and we are missing a key law of physics that governs the growth of every structure in the cosmos. There is a third, more violent explanation: the cannibal's harassment. It is possible that the Milky Way didn't just eat some of its neighbours, it may have destroyed the others before they could even form stars. This is known as galactic harassment. As these smaller systems approached, the Milky Way's intense radiation and gravitational tidal stripping may have blown away their gas, essentially sterilizing them and preventing them from ever becoming luminous galaxies. They wouldn't be missing. They would be the dead wreckage of systems that were snuffed out before they could ever shine. This is the complication. We know we are a cannibal, but we don't know if we are a cannibal in a mostly empty room or a cannibal in a room full of ghosts. The investigation is ongoing. Missions like Euclid, launched in 2023, and the upcoming Nancy Grace Roman telescope are specifically designed to search for the gravitational kinks in stellar streams that would reveal the presence of these invisible dark matter halos. They are looking for the wind by watching how it moves the leaves. But for now, we are left with an honest uncertainty. We have mapped the wreckage of the Gaia sausage and the Sagittarius dwarf, but we cannot account for the thousands of missing worlds that should be here. We are standing in a house built from the ruins of others, looking at a blueprint that says there should be thousands more bricks than we can find. The existential weight of this realization is profound. You are a citizen of a system that is constantly gaining and losing matter. You are a participant in a cycle of birth, death, and renewal that spans billions of years. Every atom in your body, the carbon in your cells, the iron in your blood, has passed through this cycle. It was forged in a star, scattered into space and gathered into a new form. And some of those atoms may have originated in galaxies that the Milky Way destroyed eons before the sun was even a grain of dust. We carry the history of the universe in our very bones, yet we do not yet understand the dark scaffolding that holds those bones together. We are small, the universe is enormous, and the fact that we can even ask these questions is the most interesting thing we know. The investigation into the cannibal's buffet is just the beginning, because as we look past the wreckage of the dead, we find that the empty space between the stars is not empty at all. It is a turbulent chemical sea that may hold the very blueprints for life, and that mystery is where we go next. Between the bright points of light you see in the night sky, there is a space we have long called the void. For centuries, we believed this space was a perfect vacuum, a silent, empty nothingness stretching across the light years. But this is a lie. Right now, in the massive gaps between the stars, you're surrounded by a structure so vast and complex that it accounts for roughly 15% of the galaxy's visible mass. You feel absolutely nothing as you drift through it. The air in your room is millions of times denser than the interstellar medium, yet in the time it takes you to blink, trillions of particles of cosmic gas have streamed through the space around you. You are moving through a turbulent, slow-motion ocean. This is confirmed science. This structure is known as the interstellar medium, ISM. It is a thin blend of gas, dust, and plasma that weaves through the Milky Way like a fog. It is not smooth or still. It is a restless sea stirred by shock waves, magnetic fields, and the violent deaths of stars. If we could see this medium with our naked eyes, the night sky wouldn't be black. It would be a chaotic, glowing tapestry of filaments, bubbles, and cavities. To understand the scale of this ocean, you have to look at how it breathes. The galaxy behaves like a living organism with a circulatory system. When massive stars reach the end of their lives and explode as supernovae, They blast gas and heavy elements back into this medium. This hot ionized gas rises out of the galactic disk like steam, rising into the halo in a process known as the galactic fountain. There, it cools, condenses, and rains back down onto the disk to form the next generation of stars and planets. This is established. Every atom in your body, from the iron in your blood to the oxygen in your lungs, was once a part of this rhythmic cycle, exhaled by a dying star and inhaled by the interstellar sea before it ever reached Earth. But as we have learned to listen to this ocean using radio and infrared telescopes, we have discovered something that defies all our traditional models of chemistry. The discovery began with a complication. We found that this empty space is actually a massive chemical laboratory. Using instruments like the ALMA Observatory, astronomers have detected over 200 different types of molecules floating in the dark. These are not just simple atoms, they are complex carbon-based compounds. We have found water, ammonia, and enormous clouds of alcohols. Most significantly, we have detected amino acids and simple sugars, the very building blocks of proteins and DNA. This is what the data says. The cargo of potential for life is drifting silently through the dark, millions of years before a planet even exists to receive it. This leads us to the heart of the prebiotic vacuum mystery, a massive gap in our understanding of how life begins. The complication is simple but profound. Space is too cold for this kind of chemistry to happen. We often imagine the ingredients of life forming in warm, shallow tide pools on a young Earth. But these molecules are found in molecular clouds, the coldest places in the galaxy, where temperatures drop to 10 degrees above absolute zero. At these temperatures, atoms should be nearly frozen in place, moving too slowly to collide and form complex structures. Heat is a distant dream in these sheltered corners. By all the laws of chemistry we use in a laboratory, these life blueprints should not exist in a vacuum. Yet, they are everywhere. To find the deeper layer of this mystery, we have to look at the dust. Interstellar dust is not like the dust in your home. It is made of microscopic grains of carbon, silicates, and ice. These tiny grains act as cosmic catalysts. They provide a solid surface where atoms can land, huddle together, and link up into complex chains. The ice crystals on these dust grains act as gentle incubators, shielding delicate molecules from the harsh, ultraviolet radiation of nearby stars. This is established science. We are finding that the galaxy seeds itself while stars are still in their nurseries. As a new planetary system forms from a collapsing cloud of gas and dust, it inherits the chemical fingerprint of its parent nebula. If that cloud is rich in water and organic compounds, those materials end up in the comets, asteroids, and eventually the oceans of new worlds. But here is where we find our honest uncertainty. Did the seeds of life form in the vacuum of space before Earth was even a grain of dust? We have long assumed that Earth was a unique Goldilocks event where the right ingredients finally met the right heat. But the data suggests that Earth might not be the laboratory at all. It might just be the destination. If the interstellar ocean is already full of life's blueprints, then the rare Earth hypothesis begins to feel incomplete. We're standing in a house built from materials that were manufactured in a factory thousands of light years away and billions of years ago. The investigation into this prebiotic mystery is reaching a tipping point. The James Webb Space Telescope is currently peering into these dark, frozen nurseries, looking for the specific infrared signatures of pre-life chemistry in the earlier stages of starbirth. We are searching for the moment when a cold, silent knot of dust becomes a cargo of potential. Forward momentum is building as we realize that the space between stars is not a barrier, it is a bridge. It is the quiet fabric from which galaxies evolve and life eventually begins. As you sleep tonight, the Milky Way continues its patient, 230 million year orbit. The interstellar ocean is swirling around you, carrying the ruins of dead suns and the blueprints for suns yet to be born. We have measured the velocity of our sun and mapped the black hole at our center, but we have not yet understood the dark chemical sea that carries us forward. We are small, the universe is enormous, and that is the most interesting thing we know. The investigation is ongoing, and the story of our origins is written in the empty spaces we're only just beginning to see. If you could somehow place the entire Milky Way on a cosmic scale, counting every star, every planet, every nebula, and every grain of interstellar dust, you would find something deeply troubling. This is what the data says. The numbers do not add up. All of the visible matter, everything that shines, glows, or reflects light, accounts for only 15% of the galaxy's total mass. Consider that for a moment. If the Milky Way were a house, it would be a structure where 85% of the rooms are locked, and the walls you see are merely a thin veneer over a massive hidden framework. You're currently sitting in a room that is mostly a ghost. The atoms of your body, your home, and the ground beneath you are just a tiny decorative fraction of the reality that surrounds you. This is confirmed science. To understand why this is a crisis of physics, we have to look at the motion of the galaxy itself. We often imagine the Milky Way as a graceful carousel of stars. According to Newtonian physics, the same laws that govern how planets orbit the Sun, objects farther from a gravitational centre should move more slowly. Mercury, tucked close to the Sun's mass, orbits at 47 kilometers per second. Neptune, drifting in the outer suburbs, crawls at just 5 kilometers per second. But in our galaxy, the rules of the solar system are ignored. This is established. When multiple independent teams measured the rotation speeds of stars at the very edge of the spiral arms, they found something that violated every model they had. Those outer stars are not slowing down. They are racing through space at roughly the same velocity as the stars near the core. Without an invisible hand providing extra gravity to anchor them, the Milky Way's outer arms should have unravelled eons ago. Based on the visible mass alone, those outer suns should be flung into intergalactic space like sparks from a spinning grinding wheel. This is not speculation. Something unseen is holding the galaxy together. This mystery is known as dark matter, and it is the invisible scaffolding upon which our entire reality is built. It does not shine, it does not reflect light, and it does not emit any radiation we can detect. It passes through ordinary matter and through your body, as if we weren't even there. Yet its gravitational presence is the most powerful force in the cosmos. To visualize the scale of our ignorance, imagine finding enormous tracks pressed into the sand of a desert. You can measure the stride length, the depth of the print, and the exact bearing of the creature that made them. You can calculate exactly how much it must weigh to press that deep into the ground. But when you look up, the desert is empty. There is nothing there but the wind. That is the state of modern astronomy. We can see the tracks of dark matter in the way it bends the orbits of stars, but we have no idea what the creature actually is. Multiple independent teams have confirmed that the Milky Way does not end where the starlight fades. We are embedded inside a massive spherical dark matter halo. This halo extends far beyond the visible disk, stretching perhaps 300,000 light-years from the galactic centre, more than 3 times the width of the spiral we can see. The glowing disk of our home is just the bright skin of a much larger, darker creature. The discovery of this invisible skeleton began in the 1930s with Fritz Zwicky, but it was solidified in the 1970s by astronomer Vera Rubin. Rubin was studying the flat rotation curve of spiral galaxies, and her data revealed that the missing mass wasn't a minor error, it was the dominant feature of the universe. Measured directly, the discrepancy is staggering. For the math to work, there must be 10 times more dark matter in our halo than all the stars, gas and dust combined. But here is where the complication deepens into a mystery that challenges our fundamental understanding of matter. The data shows that dark matter is not made of atoms. It cannot be. If it were made of normal bionic matter like protons, neutrons and electrons, it would interact with light. It would absorb it or scatter it, and we would see it as a dim fog. Whatever dark matter is, it is something truly alien. The leading candidates are theoretical particles that have never been observed in a laboratory. Some physicists propose WIMPs, weakly interacting massive particles. These would be particles with significant mass that barely interact with ordinary matter except through gravity. They would pass through the Earth, through the walls of your room, and through your body by the trillions every second, leaving no trace of their passage. Other researchers suggest axions, even more exotic and lightweight particles that could exist in such enormous numbers that their collective mass anchors the galaxy. This is the complication. For decades, scientists have built massive detectors a mile underground, shielding them from cosmic rays, waiting for just one of these particles to strike a nucleus and reveal itself. They have used tanks of ultra-pure liquid xenon and crystals cooled to near absolute zero. And after years of waiting, they have found nothing. The silence from these detectors has led some to suggest that we might be fundamentally wrong about the laws of gravity themselves. This is an honest uncertainty. Some scientists have proposed modified Newtonian dynamics, MOAND, suggesting that gravity behaves differently on galactic scales than it does on Earth. In this view, we don't need a ghost particle to explain the rotation curve. We just need a new set of equations. However, MOND struggles to explain other phenomena, like the way light from distant galaxies is bent by gravity, an effect known as gravitational lensing. Dark matter remains the best explanation we have, not because we understand it, but because the evidence for its skeleton is everywhere. We see its fingerprints in the cosmic microwave background, the afterglow of the Big Bang. We see it in the way galaxies cluster together in filaments, forming a structure known as the cosmic web. In a very real sense, the stars we see are merely the foam on the surface of a dark ocean, supported by depths we cannot perceive. Galaxies like the Milky Way only form where these dark filaments intersect. Dark matter provided the original gravitational seeds that allowed gas and dust to gather and ignite into suns. Without this invisible scaffolding, the universe would be a featureless void of cooling gas, devoid of the structures that make life possible. This is established. We owe our existence to a substance we cannot name and a force we cannot see. Right now, as you listen to this, the invisible hand of dark matter is holding your solar system in its orbit. It is providing the gravitational tension that keeps the Orion spur from flying apart. It is the silent partner in every breath you take, the dark anchor that prevents your world from drifting into the eternal night between galaxies. The investigation into this invisible skeleton is currently reaching a tipping point. Forward momentum is building with missions like Euclid, launched in 2023, and the upcoming Nancy Grace Roman telescope. These instruments are specifically designed to map the distribution of dark matter by watching how it warps the images of billions of distant galaxies. They are not looking for the particles themselves. They are looking for the wind by watching how it moves the leaves. By measuring these subtle gravitational kinks in the fabric of space, astronomers hope to create the first high-resolution map of the Milky Way's dark architecture. We are finally trying to see the skeleton of the house we have lived in for thousands of years. But for now, we're left with the profound humility of our position. We have measured the velocity of our sun and mapped the black hole at our centre, yet we still cannot identify what 85% of our home is made of. We are travellers on a bright island of matter floating in a dark ocean that remains the greatest unsolved mystery in science. As you sleep tonight, the Milky Way continues its patient 230 million year orbit, held in the grip of a ghost. You are a participant in a reality that is far more complex than anything your senses can perceive. We are small, the universe is enormous, and the fact that we're even aware of the dark scaffolding is the most interesting thing we know. The investigation continues. If you could somehow place the entire Milky Way on a cosmic scale, counting every star, every planet, every nebula, and every grain of interstellar dust, you would find something deeply troubling. This is what the data says. The numbers do not add up. All of the visible matter, everything that shines, glows, or reflects light, accounts for only 15% of the galaxy's total mass. Consider that for a moment. If the Milky Way were a house, it would be a structure where 85% of the rooms are locked, and the walls you see are merely a thin veneer over a massive hidden framework. You're currently sitting in a room that is mostly a ghost. The atoms of your body, your home, and the ground beneath you are just a tiny decorative fraction of the reality that surrounds you. This is confirmed science. To understand why this is a crisis of physics, we have to look at the motion of the galaxy itself. We often imagine the Milky Way as a graceful carousel of stars. According to Newtonian physics, the same laws that govern how planets orbit the Sun, objects farther from a gravitational centre should move more slowly. Mercury, tucked close to the Sun's mass, orbits at 47 kilometers per second. Neptune, drifting in the outer suburbs, crawls at just 5 kilometers per second. But in our galaxy, the rules of the solar system are ignored. This is established. When multiple independent teams measured the rotation speeds of stars at the very edge of the spiral arms, they found something that violated every model they had. Those outer stars are not slowing down. They are racing through space at roughly the same velocity as the stars near the core. Without an invisible hand providing extra gravity to anchor them, the Milky Way's outer arms should have unraveled eons ago. Based on the visible mass alone, those outer suns should be flung into intergalactic space like sparks from a spinning grinding wheel. This is not speculation. Something unseen is holding the galaxy together. This mystery is known as dark matter, and it is the invisible scaffolding upon which our entire reality is built. It does not shine, it does not reflect light, and it does not emit any radiation we can detect. It passes through ordinary matter and through your body, as if we weren't even there. Yet its gravitational presence is the most powerful force in the cosmos. To visualize the scale of our ignorance, imagine finding enormous tracks pressed into the sand of a desert. You can measure the stride length, the depth of the print, and the exact bearing of the creature that made them. You can calculate exactly how much it must weigh to press that deep into the ground. But when you look up, the desert is empty. There is nothing there but the wind. That is the state of modern astronomy. We can see the tracks of dark matter in the way it bends the orbits of stars, but we have no idea what the creature actually is. Multiple independent teams have confirmed that the Milky Way does not end where the starlight fades. We are embedded inside a massive spherical dark matter halo. This halo extends far beyond the visible disk, stretching perhaps 300,000 light-years from the galactic centre, more than 3 times the width of the spiral we can see. The glowing disk of our home is just the bright skin of a much larger, darker creature. The discovery of this invisible skeleton began in the 1930s with Fritz Zwicky, but it was solidified in the 1970s by astronomer Vera Rubin. Rubin was studying the flat rotation curve of spiral galaxies, and her data revealed that the missing mass wasn't a minor error. It was the dominant feature of the universe. Measured directly, the discrepancy is staggering. For the math to work, there must be 10 times more dark matter in our halo than all the stars, gas, and dust combined. But here is where the complication deepens into a mystery that challenges our fundamental understanding of matter. The data shows that dark matter is not made of atoms. It cannot be. If it were made of normal bionic matter like protons, neutrons, and electrons, it would interact with light. It would absorb it or scatter it, and we would see it as a dim fog. Whatever dark matter is, it is something truly alien. The leading candidates are theoretical particles that have never been observed in a laboratory. Some physicists propose WIMPs, weakly interacting massive particles. These would be particles with significant mass that barely interact with ordinary matter, except through gravity. They would pass through the Earth, through the walls of your room, and through your body by the trillions every second, leaving no trace of their passage. Other researchers suggest axions, even more exotic and lightweight particles that could exist in such enormous numbers that their collective mass anchors the galaxy. This is the complication. For decades, scientists have built massive detectors a mile underground, shielding them from cosmic rays, waiting for just one of these particles to strike a nucleus and reveal itself. They have used tanks of ultra-pure liquid xenon and crystals cooled to near absolute zero. And after years of waiting, they have found nothing. The silence from these detectors has led some to suggest that we might be fundamentally wrong about the laws of gravity themselves. This is an honest uncertainty. Some scientists have proposed modified Newtonian dynamics, MOND, suggesting that gravity behaves differently on galactic scales than it does on Earth. In this view, we don't need a ghost particle to explain the rotation curve, we just need a new set of equations. However, MOND struggles to explain other phenomena, like the way light from distant galaxies is bent by gravity, an effect known as gravitational lensing. Dark matter remains the best explanation we have, not because we understand it, but because the evidence for its skeleton is everywhere. We see its fingerprints in the cosmic microwave background, the afterglow of the Big Bang. We see it in the way galaxies cluster together in filaments, forming a structure known as the cosmic web. In a very real sense, the stars we see are merely the foam on the surface of a dark ocean, supported by depths we cannot perceive. Galaxies like the Milky Way only form where these dark filaments intersect. Dark matter provided the original gravitational seeds that allowed gas and dust to gather and ignite into suns. Without this invisible scaffolding, the universe would be a featureless void of cooling gas, devoid of the structures that make life possible. This is established. We owe our existence to a substance we cannot name and a force we cannot see. Right now, as you listen to this, the invisible hand of dark matter is holding your solar system in its orbit. It is providing the gravitational tension that keeps the Orion spur from flying apart. It is the silent partner in every breath you take, the dark anchor that prevents your world from drifting into the eternal night between galaxies. The investigation into this invisible skeleton is currently reaching a tipping point. Forward momentum is building with missions like Euclid, launched in 2023, and the upcoming Nancy Grace Roman telescope. These instruments are specifically designed to map the distribution of dark matter by watching how it warps the images of billions of distant galaxies. They're not looking for the particles themselves, they are looking for the wind by watching how it moves the leaves. By measuring these subtle gravitational kinks in the fabric of space, astronomers hope to create the first high-resolution map of the Milky Way's dark architecture. We are finally trying to see the skeleton of the house we have lived in for thousands of years. But for now, we are left with the profound humility of our position. We have measured the velocity of our sun and mapped the black hole at our centre, yet we still cannot identify what 85% of our home is made of. We are travellers on a bright island of matter, floating in a dark ocean that remains the greatest unsolved mystery in science. As you sleep tonight, the Milky Way continues its patient, 230 million year orbit, held in the grip of a ghost. You are a participant in a reality that is far more complex than anything your senses can perceive. We are small, the universe is enormous, and the fact that we're even aware of the dark scaffolding is the most interesting thing we know. The investigation continues. In the time it has taken you to listen to this investigation so far, a massive structure containing 1 trillion stars has moved roughly 40,000 kilometers closer to you. High above the horizon, the Andromeda Galaxy appears to your naked eye as nothing more than a faint misty patch of light, a ghostly blur smaller than the moon. It looks peaceful, it looks static. But this is a lie. Andromeda is currently hurtling toward us at a velocity of 110 kilometers per second. To put that speed in perspective, in the time it takes you to take a single breath, that galaxy has closed the gap between us by the distance of a marathon. If you could drive your car at that speed, you could travel from New York to Los Angeles in less than 40 seconds. And yet, because the distance between us is so vast, roughly 2.5 million light-years, your retinas perceive no motion at all. To our ancestors, it was a fixed point. To us, it is a freight train on a track we share. We are on a collision course with destiny, and this is confirmed science. If you enjoy these deep investigations into the mechanics of our reality, subscribe now. The investigation continues with the realization that our home has an expiration date, and we are being pulled toward a future we cannot avoid. For decades, astronomers believed the universe's expansion would eventually carry Andromeda away from us. But the data has overturned that assumption. While the universe at large is expanding, the local gravity between our two galaxies is strong enough to overcome that expansion. We are locked in a gravitational embrace that will only end in a titanic merger. But here is the complication. When these two giants meet in roughly 4 billion years, the word collision will not mean what you think it means. You might imagine the sound of metal rending and the fire of stars crashing into one another like cars in a highway pileup. But galaxies are made mostly of empty space. The distance between individual stars is so unimaginably vast that during the entire merger, almost no stars will ever hit each other directly. The stars of Andromeda will simply pass through the spaces between the stars of the Milky Way, like two swarms of bees flying through one another. Instead, the violence will happen on a structural scale. As the galaxies draw closer, their mutual gravity will begin to stretch and twist their shapes. The elegant spiral arms we have spent tonight exploring will be shredded. They will be pulled into long glowing ribbons of stars known as tidal tails that will arc tens of thousands of light years into the dark void. The night sky of Earth, if our planet still exists, will be filled with breathtaking vistas, sheets of light and brilliant new star clusters ignited by the compression of gas clouds. Eventually the two spirals will lose their identities entirely. They will pass through each other, separate briefly, and then be reeled back in by gravity for a second, more intimate pass. After billions of years of this slow-motion choreography, they will settle into a single, massive structure. Astronomers have already given our future home a name, Milky Way. This new galaxy will likely be a giant elliptical galaxy, a smooth, glowing sphere of stars with no spiral arms and very little remaining gas to form new suns. The two supermassive black holes at our cores, Sagittarius A star and Andromeda's central monster, will spiral toward each other in a death dance, eventually merging into a single engine of unimaginable power, releasing a burst of gravitational waves that will ripple across the entire universe. We often think of our galaxy as a permanent monument, but the history of the cosmos is not written in stone, it is written in motion. The Milky Way is merely a temporary phase in a much longer story of transformation. But as we look toward this future merger, a deeper complication has emerged. We have discovered that our entire fleet, the Milky Way, Andromeda, and the 50 smaller galaxies of our local group, is not merely drifting. We're all being pulled together towards something else. This is what the data reveals. While we're racing toward Andromeda, the entire local group is being drawn through space at hundreds of kilometers per second toward a gravitational anomaly located roughly 150 to 250 million light-years away. Astronomers call it the Great Attractor. It is a concentration of mass so immense that its pull influences the motion of tens of thousands of galaxies across a region of space spanning hundreds of millions of light-years. To visualize this, imagine the universe as a vast topographic map. Most of the cosmos is a flat plane, but the Great Attractor is a deep gravitational basin. Every galaxy in our neighborhood is like a drop of rain hitting the side of that basin, slowly but inevitably flowing toward the bottom. But here is the mystery that defines our current ignorance. We cannot see what is pulling us. This region of space lies directly behind the thickest part of the Milky Way's own disk. For decades, the very stars and dust we call home have acted as a cosmic blindfold, blocking our view of the most powerful force in our neighborhood. Astronomers call this hidden region the zone of avoidance. It is a wall of dust so dense that visible light cannot penetrate it, leaving us to guess at the nature of the monster that commands our trajectory. We have attempted to peer through the fog using X-rays and radio waves, which can slip past the dust. These investigations have revealed a dense concentration of galaxy clusters, including the Norma cluster, sitting at the heart of the anomaly. But even that does not seem to be enough mass to explain the sheer velocity at which we are moving. This leads us to a deeper layer of the investigation. We now know that the Great Attractor is just one part of a much larger structure known as the Laniakea supercluster. This is our true cosmic address, a massive web of filaments and flows containing 100,000 galaxies. We are passengers on one small thread of this web, being drawn toward a common centre of mass that we are only just beginning to map. And here is where we find our honest uncertainty. We do not know exactly what sits at the absolute centre of the Great Attractor. Is it an unimaginably large concentration of dark matter? Is it a structure so vast that our current laws of physics struggle to categorize it? We only know that it is drawing us toward a destiny we cannot stop. However, there is a final twist to this cosmic journey. Despite the incredible speed at which we are falling toward this anomaly, we will likely never arrive. The data shows that a mysterious force called dark energy is pushing the universe apart even faster than gravity can pull it together. On the larger scales, the space between galaxy superclusters is expanding so rapidly that the Great Attractor may eventually be pushed beyond our reach. We are falling toward a destination that is simultaneously receding from us. We are travellers on a moving world, caught between a gravitational pull toward a dark centre and an expansive push toward an eternal lonely dark. The existential weight of this realization is profound. We have mapped the velocity of our sun and the orbits of the stars, but we're still like those ancient navigators on a ship with no shore in sight, carried by currents we can measure but not control. As you sleep tonight, the Milky Way continues its patient 230 million year orbit, carrying us closer to Andromeda and deeper into the gravitational basin of Laniakea. We are participants in a 13 billion year old dance that is far from finished. We have measured the shadow at our core and seen the ghosts of the galaxies we have eaten. We have heard the great silence and peered at the dark scaffolding of the universe. Yet every fact we uncover reminds us of the same fundamental truth. We are small, the universe is enormous, and that is the most interesting thing we know. The investigation is ongoing, and the story is just beginning. We have spent this investigation peering into the dark, counting the shadows, and measuring the ghosts that haunt our home. But as we reach the end of these 100 mysteries, we must confront the most profound truth of all. The investigation does not end with a map. It ends with a mirror. We are living inside a 13.6 billion year old system that is still growing, still breathing, and still keeping secrets. To understand that number, 13.6 billion, you have to step outside the scale of a human life. If the entire history of the Milky Way were compressed into a single 24-hour day, the entire history of human civilization would occupy less than the final tenth of a second before midnight. We are newcomers to a story that was already ancient, before the sun was even a thought in a collapsing cloud of gas. This is confirmed science. Our galaxy is not a static backdrop or a silent monument. It is a dynamic, living structure. It breathes through the galactic fountain, a massive respiratory system where dying stars exhale hot gas into the halo, only for it to cool and rain back down to trigger the birth of new suns. It grows by devouring its neighbours, currently unravelling the Sagittarius dwarf galaxy like a thread from an old sweater. We have measured the velocity of our sun. We have mapped the shadow of the supermassive black hole at our core. We have even listened to the silence of the Fermi paradox. Yet, despite our sophisticated instruments, we are still like those ancient astronomers looking at the Silver River, trying to understand a house from the inside of a single room. This brings us to the human translation of these cosmic mysteries. It is easy to feel small when discussing hundreds of billions of stars, but you're not merely a spectator to this system. You are a participant in its chemical history. This is not speculation. Every atom in your body, the iron in your blood, the oxygen you breathe, was forged in the same stellar nurseries we explored tonight, consider the iron that carries oxygen through your veins. That iron did not exist when the universe began. It was manufactured in the white-hot core of a massive star, a celestial furnace that burned for millions of years. When that star exhausted its fuel and collapsed, it exploded with a violence that outshone the rest of the galaxy combined. Measured directly, that explosion scattered the star's remains across the interstellar ocean, enriching the gas clouds from which our own solar system would eventually form. The gold on your finger was forged in the even more violent collision of two neutron stars, city-sized corpses crashing together in a flash of light called a kilonova. You are a mosaic of stellar deaths. You are a collection of atoms that have cycled through the galaxy for billions of years, taking different forms, joining different structures, until finally coming together in the pattern that is you. This leads to a deeper existential reflection. We have spent the last century mapping the stars with exquisite detail. We have sent the Gaia mission to track the movements of over 1 billion suns. We have used the James Webb Space Telescope to peer through the dust fog and see the first flickers of creation. Yet, all of that mapping accounts for only a tiny fraction of our home. Everything we can see, every star, planet and cloud, accounts for only 15% of the galaxy's mass. This is established science. The remaining 85% is dark matter, an invisible scaffolding that holds the spiral arms together. Without this invisible hand, the outer stars of the Milky Way would be flung into the dark void like sparks from a spinning wheel. We are passengers on a bright island of matter floating in a dark ocean that we cannot see, touch, or name. We have mapped the stars, but we have not yet understood the dark. We are the way the universe chooses to look back at itself and ask, why? If the Milky Way is a puzzle box, we are the conscious part of the puzzle that has begun to solve itself. In the 13.6 billion years of our galaxy's history, we are among the first to develop the eyes to see the spiral and the minds to weigh the black hole. Whether we are the only ones asking these questions remains the heaviest fact in modern science. The great silence. If we are alone, then consciousness is a fragile, precious miracle that the galaxy has produced only once in 13 billion years. It makes our survival the most significant event in the cosmos. If we are not alone, then we are part of a larger community of minds, all looking up at their own version of the Silver River, wondering if anyone is looking back. The investigation is ongoing. Forward momentum is building as you sleep. Right now, new missions like Euclid and the Nancy Grace Roman Telescope are being prepared to map the invisible dark matter halo. We are searching for the wind by watching how it moves the leaves of starlight. We are developing neutrino astronomy and listening for gravitational waves to hear the whispers of the core that light cannot carry. As you close your eyes tonight, the galaxy continues its patient 230 million year orbit. Your coffee may be still and your room may be quiet, but you're part of a current that never stops. In the time it took you to hear this final thought, you have moved another 100 kilometers through the dark. You are a traveler aboard a moving world on a journey you can neither steer nor stop. We have measured the velocity of our sun and seen the ghosts of the galaxies we have eaten. We have peered at the dark scaffolding of the universe and heard the silence of the stars. Every fact we uncover pulls the ground slightly further from under our feet, yet it also anchors us more deeply to the story of our home. We are small, the universe is enormous, and that is the most interesting thing we know. The investigation continues. Good night, Stardust.